everyone. I'm really excited to be here and see so many people, so that's really awesome. Thank you very much for having me. So my name is Justina and I work at Rasa, which is a Berlin-based startup, and we are working on open source software for conversational AI. I am a developer advocate, so I work on machine learning and do a lot of engineering stuff, but also I meet developers, and my goal is to make sure that developers have all the tools and resources to understand how Rasa works and how machine learning behind Rasa works, and also how to build something great with Rasa. Today I just would like to talk about how you can use machine learning and open source tools to build AI assistants that go beyond the simple FAQ interactions. Let's begin. Over the past few years, we definitely saw a big change in technology around us. So while just a few years ago, companies focused on building great web apps and websites, and then turned into mobile apps. In the past year or two, we have seen a big change and in acquisition and attention for conversational AI assistants. So you probably have already saw and probably almost definitely used AI assistant at some point, or Siri. And with the technology and the research in the field moving so quickly forward, it's going to be even more prominent, and they are going to be even bigger part of our lives. And because of that, Rasa exists. But our goal is not to build assistants themselves, but to allow any developer out there to be able to build their own conversational AI. As a result, we developed a framework which is called Rasa Stack, and it is open source framework that allows developers to build their own conversational AI assistants. It consists of two open source libraries. First one is called Rasa NLU, which, just like the name suggests, is a library for natural language understanding, so allowing an assistant to understand what the user means. Another library is called Rasa Core, which is a machine learning-based framework for dialogue management, so allowing an assistant to think how to respond and what kind of actions to execute. And they work together, or developers can use one or another if they want to. So why Rasa? Why would you want to use it, and why it should be included in your toolbox? So a couple of things. So first of all, it runs locally or wherever you want. So you can choose if you want to run your assistant on your local machine, on the cloud, on a dedicated server, or anywhere else. Also, another one is really important: you own your data. So since Rasa is open source and you run your assistants wherever you want, we never see any interactions that your users have with your assistant, or we don't get any data that you use to train your models. And also you avoid the vendor lock-in. So it's not like we would take your data and close the tool or do something with it. It's yours. You can do whatever you want with it. And the biggest advantage of open source is that it's hackable. So you can see everything that is under the hood, all the code, all the models, and you can tune the models, you can change them, you can add your own models, your own custom components. So it's really a lot of fun and a lot of freedom for developers to really customize entire framework to best suit their needs. So if you wanted to build an assistant with Rasa Stack, this is how the overall architecture of an assistant would look like. It's quite simplified. So let's say we have a user and they want to change their address. Let's say I just moved to Berlin and I want to change my address. So the first stage this message would go through is a connector module. So this is where you could use any voice or messaging platform of your choice, like Messenger or Slack or any other platform you want to. And then this message would go through the input module, so-called ears, and this is where Rasa NLU model stands. It takes the message, crunches it, extracts the necessary details, and passes them to dialogue management model, so-called brain. And this is where an assistant thinks how to respond. And those responses can be either simple text responses or some kind of actions, and those actions can be a lot of things as well. So they can be backend integrations. I hiding here. Backend integrations like API calls or connections to the database and getting some data that an assistant needs to respond. And then once it has all the details to provide the response, output module, so-called mouth, is responsible to take those details and create a response in a simple human language that a user can understand and sends it back to the connector module. And then a user gets the response, for example, what's your address. So that's a very simplified version of that. So now I would like to get a little bit deeper and to explain you how each piece in Rasa Stack works. Also get a little bit deeper into machine learning behind both of these components, NLU and dialog, and explain you more what's happening. So I will start with Rasa NLU and NLU part. So the main goal is to enable an assistant to understand what the user is asking or saying. And the goal of Rasa NLU is to take unstructured user input in a simple human language and extract structured data. So this data consists of two main components. First one is called intent, which is a label that can be assigned to the user input, which represents what is the overall intention of this input. And another piece is called intent, or it can be a lot of intents, which are important pieces of information that an assistant has to extract and use them to better understand the user's input and also to make more accurate answers. So for intent classification, in Rasa NLU, you actually have quite a few choices of how you can approach the problem. And it really depends on the use case, what kind of users you're going to have, and also what kind and how much data you will have to train the models. So there are two options. One is to use pre-trained word vectors, and another one is supervised word vectors from scratch approach, which doesn't use any word vectors. So I'm going to explain you both, and when and why you should consider use one or another. So the first option, using pre-trained word vectors. Oh, too much. Pre-trained word vectors, basically that's how the how it suggests is that you take already pre-trained word embeddings, for example, love word embeddings or maybe fast text, and you use them in your model. So in Rasa NLU, when you have a new user input, this input goes through the vectorization stage, which means that we look up word vectors for each of the words in a sentence, and they are passed to the intent classifier, which then produces the label of the intent. How it works under the hood? Well, it's actually quite simple. We use bag of words, and the next stage is to create sentence representation of the sentence. To do that, we use average word embeddings approach, so basically we average vectors. It's a very simple, quite naive, but really powerful and really good approach to get quite good results. And then we feed these features into the classifier, for example, SVM, which produces one of the most probable label that should be assigned to the user input. And it's a multi-class classification problem, which means that if in your training data you had 10 or 20 possible intents, then the model will predict one of them. So when you should use this approach? You should use this approach, pre-trained word vectors approach, if you have a small training data sample, because by using pre-trained word vectors, you already have semantic similarities of the words learned. So your model will not have to learn that. Your model will be simpler. You will need less training data to build quite a decent model. So it's a good starting point for any chatbot. Also, this approach works well. Well, it's kind of a drawback in a way. It works if you have the vocabulary, which is quite simple in a way, that doesn't have any specific terms or words or something like that. So for example, if you build hotel search assistant or something like that, it's a good approach to get started. So, but this approach also comes with some limitations. So since we are using just a simple classifier, it means that we can assign only one intent label to one user input. But things don't really work that way, and Like when we talk to our friend or to colleague, sometimes when we say something or when we send a message, this one message can have more than one intention. So if we want to build assistants that are good and feel natural, we have to tackle these issues as well. And for that reason, we at Rasa developed another approach, which is the supervised vectors from scratch approach. And the main idea is that this approach allows an assistant to learn to assign more than one possible intent to one user input. So here I have just a few examples of how that looks like. For example, when the user says, "Sounds great, can you also tell me what is the price?" Let's say some kind of e-commerce chatbot. An assistant should understand that the user said something yes, that the user is happy about something, and that it is also asking about the price, and things like that. So in Rasa NLU, this approach is called supervised vectors from scratch, or the model itself is called TensorFlow embedding model. So this model was inspired by Starspace, which is research made by Facebook. They wrote a really great paper on that. So if you want to learn more details about this model itself, I would definitely recommend reading that. But the main idea is that it's not really a classifier, it's a ranking model, which means that the model learns embeddings not only for the user input, but also for all of the intents. And then once the new message comes in, the algorithm calculates the similarity between user input and all of the intents. And after optimizing the loss function, it produces the set of the most probable intents. So when to use this approach? Obviously, you should consider this approach if you have more training data, because since you don't use pre-trained vectors, the model has to learn more things just using the training data you have in your training data file. But it comes with a lot of advantages. So since you don't use pre-trained vectors, you can build assistants in any language. So you're not limited to specific languages that has pre-trained vectors. So also you can then build assistants that understand more than one intent per input. And also if you have a very specific vocabulary with very specific terms, with very specific words, this is a good approach to tackle these kind of problems, because since your assistant will learn word embeddings from scratch, it is way more likely that it will pick up some unusual terms in your vocabulary. So this is intent classification, but another part is entity extraction. And now let's take a look at how this part works. So it's actually quite similar process, but just a little bit longer. So when there's a new user input, this input is tokenized, so a token is one word, for example. And we use feature extractor, which extracts specific features that are fed to the model. And we train the named entity recognition model, which produces the output, which you can see right here, which is the value of the entity, for example, tomorrow in this specific example, and the type or label of this entity, because there can be more than one possible date in a user input. So in more detail, how that works. So let's say we have a user input, what's the weather like tomorrow in Berlin? The algorithm that is used in Rasa by default is conditional random fields. Obviously you can change that if you want to use something else. And the result is the entity and the label. Under the hood, how that works is the model, the CRF, works in a similar way as a skip graph model. So it takes a target word, for example, tomorrow, and it also looks at surrounding words. So the word before, the word after. And with this feature extractor, what we do is we extract specific features about the words. So for the words before, for example, we can check if it is lowercase, if it is a title, or if it's an uppercase word. For the target word, there are lots of different features. I don't have all of them written here. But for example, we can look at the prefix, so what are the first 5 characters in the word, suffix, what are the 3 last characters in the word, and so on. And for the after model, after word, we have a set of features here as well. So just by looking at, during the training stage, when the model sees all these features and sees the labels for specific entities, it learns that if there is a specific word with these specific features and surrounding words also have specific features, it learns that some specific words in a sentence are entities. So this is about NLU part. Another stage is dialogue management, and now let's take a look at how that works. So, why dialogue management with Rasa Core and how it's different in general? The main idea is with Rasa Core, you use real conversational data and machine learning. So there are quite popular approaches when it comes to dialogue management, which are writing rules or creating state machines. With Rasa Core, you don't do that at all. Instead, you observe how users converse with your assistant, and using that data, you build models that then learn and predict how an assistant should behave and respond. Another thing is that with Rasa Core, you can close the feedback loop, which means that you can incorporate real-time user feedback, which helps improve your assistant. And also, with Rasa Core, you don't need a lot of training data to get started. You can build something that runs in, I would say, 20 to 30 minutes. So you don't really need to put a lot of work to quick start. Obviously, if you want to build something that runs in production, you will need to spend more time. And then you use machine learning and leverage that to make your system good. And especially, it's a very powerful way to approach dialogue management when you want to build something that runs in production. Because the issue really is that when you want to build a production-ready assistant, it's going to be quite big. Lots of different actions, lots of different things. So it's a lot easier to collect more training data and add that and train the model and improve that way, instead of going through the huge architecture of state machines or rules and see where to put another rule in your assistant architecture. So Rasa Core allows your assistant to learn from real conversational data. And here I have just one example of how this conversational data looks like. So on the right-hand side, you can see an actual conversation. It's about hotel booking, so user says something, a chatbot responds something. And on the left-hand side is exactly the same conversation. It's just converted into the Rasa format, which means that user inputs have intents assigned, while the responses of an assistant has actions assigned. In the end, it's the actual conversation between the user and an assistant. So how it works under the hood. So let's say we have a user who asks about the weather tomorrow, so I'm using the same example. The model that is under the hood, and that is a default model, is a recurrent neural network. And then obviously, Rasa NLU does its job. It predicts intents and entities. And then first thing that goes into the model are previous states of the conversation, so what happened before, because it's important for an assistant to keep the context of what happened throughout the conversation. So you can specify that, how many steps you want to include. This is just an example. There is a parameter called max history. So if you say that I want to include 3 previous states, you set that, and but it depends on your use case and your preference. And then once that is fed, we deal with a current state. So what the user said now. So a current state in this example would be the current question about what's the weather like tomorrow. And then once the model has all the details, and obviously it extracts features and so on, it makes the prediction of what would be the best and the most probable action that an assistant should execute at that specific state of the conversation. Those actions, as I have mentioned, can be a lot of different things. They can be API calls, or they can be some kind of responses that an assistant just simply says something. And if action is, for example, an API call, an assistant can extract some additional details that should impact the dialogue later on. So if an assistant extracts important details, for example, temperature here, it can set them as a slot and then feed them again to the recurrent neural network for the next predictions in the future. And then in the end, obviously, at some point, an assistant makes the response and gives the response back to the user. So this is the overall architecture of the dialogue management. Another important part is closing the feedback loop. So I have mentioned that it's important to gather feedback from the users, or even you as a developer, you should be able to train your model as you talked it, and this is what interactive learning is called in Rasa. And the main idea is that you can talk to your bot, and an assistant tells you what it thinks, how it understood you, and also what it thinks it should do next and how it should respond. But if it made a mistake, you can tell your assistant, you made a mistake, you should have done this instead or said this instead, and then assistant learns from that feedback. Yeah, and it corrects itself. I'm not sure if I can show that. Okay, I'll probably skip. So here I just wanted to let you know that even though we don't build bots, so we have only we provide software to developers, we actually built one assistant with Rasa. So if you head to Rasa Docs, which is rasa.com/docs, you will see an assistant called Sarah, and you can chat it, and you can see how an assistant built with Rasa works, and just basically try to break it or just have a good conversation about Rasa. Yeah, and then I will just wrap up. Just a few takeaways and some tips that I have learned while working with developers and helping them out with their issues. So real users, help real users to improve your assistant. It's really important because even though you can sit down and generate a lot of training data yourself, write NLU examples and even conversations between the user and an assistant, it's important to give an assistant to the users as early as possible, because they will always surprise you, and you will always be quite surprised how they actually talk to your assistant, and you will get a lot of good training examples to make your assistant even better. Also, how to get started. Like, sometimes it's really tricky because conversational data is not something that just lays around. So if you have no training data to get started, just look at how your users interact with your website, or like maybe you can have logs of customer services questions, and you can use that data already to at least plan out how the conversation could look like and what are going to be the main queries that the users will have with your assistant. Also, don't be afraid to customize the tools you use, because I don't think there is one tool that fits all use cases. So the best part of open source, again, you can customize everything. So really think about what kind of problem you're dealing with, and don't be afraid to customize. Yeah, and then start small. I see a lot of developers kind of diving in and building assistants with hundreds of different actions and so on. My advice would be start small, make sure your assistant nails the happy path, so the most probable questions and those basics that your assistant should be able to handle. Because if your assistant will fail at the happy path, it's not going to provide good user experience, even though you will try to build it like kind of can do it all assistant. And even though we are putting a lot of work into making sure that Rasa Stack works well, NLP is far from being a solved problem. There are still so many challenges out there, like negation, like multi-domain assistance, and so on. So we are working on open source community as well. So we are building the community around Rasa tools. So if you are interested in contributing, if you're interested in involving yourself into this really exciting field, definitely check it out and join our community, because we are all about open source, community, and applied research that all developers can use. Yeah, so I will finish it here. I hope you learned something new, and I hope you're going to try out Sarah and Rasa. If you have more questions, I don't know if I have any time left, but if you have questions, you can ask now, or you can send me them on email. You can find me on Twitter. I'm always happy to chat and answer any questions. Okay, thank you very much.